before. So today, well, first let's see what we've been doing. Yesterday before, you solved systems of equations in two variables. We did that a couple of days ago. So you solved systems where they hit 1 point, and that was the point was the answer, the solution. And then we solved systems of equations, systems of inequalities. We had shading to see where they intersect. Well, today we are going to do systems with 3 variables. So instead of just an x and a y, we're going to have an x, a y, and a z, which gets into kind of the part of graphing and math, because we have to think 3-dimensional. And even though we see in 3 dimensions, it's very hard to draw 3 dimensions. So we have to kind of use our imagination as math people when we try to figure out how to draw 3-dimensional. But let me show you kind of what these are going to look like. You're going to have systems like this. Don't write this down. Just kind of look at it. Notice we have x's, we have y's, we have z's. This is supposed to be a 5. And if you have 3 variables to solve for, you've got to have 3 equations to work with. In the same way, when we had 2 variables to work with, we had to have 2 equations to solve for them. And so that's why we call them 2x2s, or this would be considered a 3x3. You have 3 equations, 3 unknowns. And what the solution is, instead of, it's not going to be 2 points intersecting, it's not going to be 2 shaded areas intersect, 2 or 3 shading areas, it's going to be 3 planes intersecting. 3 planes intersecting. What does that mean? Well, it's easier just to, let me show you this picture. I can't draw 3-dimensional. So let's look at, can we kind of visualize this? So the red plane is one of those x, y, z equations. The green one is another. Let me turn these lights off so you see better. The green is another plane. The blue is another plane. Can you kind of picture that? So they can intersect a lot of different ways. It's not like lines. They can just intersect, either they do or they don't, or they're the same line. But look at this one. If they were arranged like this, then right in the center, they all come together at a point where all 3 of those planes come together. If they were intersecting like this, they all come together on a line. So your answer could be a line. Here, your answer is a point. Or there's 3 ways where how they have no point of intersection. If you arrange them like this, kind of in a triangle, they never have any points in common. If you arrange them like this, you wouldn't have any points where all 3 of them have in common, or that last one. So they're parallel planes, if you will. Right? And obviously it's very hard to draw those. Usually what books do, we're not going to do a lot of this because it is so, how do I say this? It's so hard to do. Most books will do this. They'll say, okay, we've got x, y, and z coming out like this, and you have to somehow envision that z is actually coming out here. Well, how do you draw a line coming out towards you? You see how it's kind of hard to do. But so there, in the older days, we used to graph according like this, but it's just so not realistic. But now that we have computers that do, and aren't y'all taking the program in what I used to call SHA, but industrial, there's CAD, it is, 3-dimensional, and you can turn it around and see all sides of it and stuff. That's what we need in here, really, kind of visualize how that works. But I'm not going to attempt to draw 3-dimensional. But I want you to have that in mind as we solve these. The only ones that we're going to work with, though, in this class, I shouldn't say the only ones. The majority of the ones we're going to work with, they're going to be intersecting at a point. Okay? Some of these others are kind of crazy. But we're going to be mainly doing the ones that intersect at a point. Occasionally we'll get a no solution, which one of these. But mathematically, I'll show you what that looks like. I would suggest that you not, once you put your pencil down, do not take notes this first time when you solve these, because if there's a lot to it, but I want you to see the big picture before we start taking notes. Okay? You'll have to plan. I'll give you time in a minute to do one, so you'll have it in your notes. All right. I'm going to use elimination. And the first thing I'm going to do is I'm going to look and see, are there any natural eliminations between any of the x's? Are any of the x's opposite from one another? No. Are any of the y's opposite from one another? No. Any of the z's? No. So there's no natural way to start eliminating. So honestly, you just choose. What would be easy? Find one that would be a little easier to kind of make it go away. If you just did two of them, just pick two to do. I'm looking at this one and this one. Because I see this is a negative 3y, this is a y. So if I multiply this bottom one by negative 3 on both sides, that would turn that into a 3y. But you could have chosen something else. You pick anything you want. I'm gonna get rid of these two x's here. I'm going to multiply, what am I doing? This one by negative 3. So that's going to be negative 18x plus 3y plus 4z equals 1. And I'm comparing it to, or putting it together with this one, which is 2x. Yes. Absolutely, I should. Absolutely, I should. I just forgot that. Thank you, because that messed me up later. So this is minus 12c equals positive. So I'm going to just rewrite this one as it is. So that's minus 3y plus 5c equals negative 14. And then I'm going to act like I just have a system of 2. So this is going to be a negative 16x. These y's are going to cancel. This is a negative 7z equals negative 11. Please do catch me if I make mistakes, because there's a lot of places you can make mistakes. Now, here's the key. Since I chose to get rid of y's first, now I need to go back and get rid of y again in two other equations. Right? I need to choose the same variable and get rid of it twice. So, which two do you want to put together this time to get rid of the y's? Maybe this one and this one? Because here, this is a 2y, this is a negative y. So this time, if I just multiply this one by what? 2 on both sides, then I can put it, you know, alright, so let's multiply this bottom one by 2. That's going to give me 12x minus 2y plus 8z equals negative 2. I'm going to compare it to this top one, which is 4x minus 2y plus 3z equals 1. Plus 2y on the bottom, y. I'm doing 2 times negative y. This is that one. Okay, 12x minus 2y. This one? Yeah. Oh, I just wrote it down wrong. Thank you. Okay, good. So now let's do those together. So now I've got 16x plus 11z equals negative 1. Now look at these two. Now I've got two equations with two unknowns. Well, that's what we had last night. I can solve those. So I'm going to stick these two together and solve it like a 2 system, a 2 by 2. So I'm going to take this 16x plus 11z equals negative 1. And I'm going to put it together with negative 16x minus 7z equals negative 11. Ooh, this is sweet because the x is already set up to cancel. That doesn't always happen, sometimes you have to manipulate it to make it happen. This one did. So those cancel. This gives me what, a 4z equal negative 22. What is negative 22? Negative 12. Negative 12. So what's z going to be? Negative 3. I'm a third of the way there. Because remember, your answers are going to be a threesome now, x, y, and z. I know my z is negative 3. But really, the hard job is done. Because now what you're going to start doing, now what you're going to do is you're going to go back upstream. Once you get to this point, you're going to go back upstream. You're going to take this negative 3 that you got here, this negative 3, and you're going to put it back up into one of the places where you only had 2 variables. So I can take the negative 3, stick it in for z right here. And when I do that, I get 16x plus negative 33 equals negative 1. So 16x equals, I bring the 33 over, that'll be positive 33 minus 1 will be 32. So x equals 2. So I got my x. Be sure to put them in the right spot. X, y, and z. That order. So now I have this z, I have this x, so I have 2 of the 3. So where do you think I'll plug those two? Back into one of the original. So I'm going to go back upstream again. And I'm going to put in, I've got my x and my z. So I'm just going to go to the first equation. You can do either one, but I'm going to go to the first one. Actually, I should go back to the original. You could go back here, but I'm going to go back to the original, just to make sure I'm not making mistakes about mistakes already made. So I'm going to do 2. I'm up here 2 times x, which x I know to be 2, minus 3 times y. I don't know why. 5z, my z is negative 3. And that needs to equal negative 14. Do the math. 4 minus 3y minus 15 equals negative 14. Negative 3y minus 11 equals negative 14. Negative 3y equals, bring that over, negative 3, okay. Y equals 1. Ooh. Well, that is your answer, but yes, if you wanted to test it, yes, you would plug that in all 3 equations. Yeah, I felt very confident. What do you think? So, it's kind of long. I'd give it to you. It's long. You won't have a lot of these on a test. You won't have a lot of these, on a homework assignment, but you've got to practice it to do it. So, let's do one. You do this one. And it'll take you a while. Give it a shot. All right, so the first thing I see on this one personally is that I've got a negative 5z here and a positive 5z here. So, and actually, I'm going to go through this, do this too. I'm going to call this number 1, number 2. Guys, please don't talk, because there are people who are really, really confused, okay? I'm just going to label them so I know what to talk about. So I'm going to put number 2 and 3 together because the z's naturally cross out. So here goes 2 and 3 I'm putting together. So I'm putting together 6x plus 4y minus 5z equals negative 7. Together with negative 4x minus 2y plus 5z equal 9. So this is going to give me a 2x plus 2y. Those cancel 2. Okay? All right, now I got rid of the z. So I got to get rid of the z again. So I've got to go back to the original 3 problems and pick 2 other ones to get rid of the z. None of them are going to be easy because all I have is 6 and 5s and 5s. So just for grants, I'm going to pick number 1 and number 2. Put together. Pick 1 and 2. And as I do it, I'm going to go in and get the z's without cancel. So I'm going to multiply this top one by 5 all the way across, and the second one by 6 all the way across. So that's going to give me my first equation then. I'll have 10x minus 5y plus 30z equal negative 20. For my second equation, I'll have 36x plus 24y minus 30z equals negative 42. So that's going to give me 46x. This is going to give me 19y. Max, this looks familiar to yours. Equals negative 62. All right. So now I've come up with, I'm going to keep the negative. I'm going to call this one number 4 and this one number 5. Right now, 4 and 5 only have x's and y's in them. So I'm going to put 4 and 5 together. But while I do, I'm going to make one of those cancel. So I'm going to multiply number 4 by 32, actually a negative 32, so that I can make it a negative 46 when I get rid of that x. Oh, like I said, negative 23. So negative 23 on both sides of that. All right, so this is number 4. I'm going to write down, having multiplied by negative 23 equals 2. So that's going to give me a negative 46x minus 46y equals negative 46. Please stop me if I mess up. 5, I'm going to write it down as it is. 46x plus 19y equals negative 63. All right. Let's cancel. Help me do this math for me. What's 46 minus 19? Okay, 27y equals, I need to add those together. And that'll be negative 108. And now divide both sides by negative 27. I think I'm getting 20. So, my y is 4. And he goes in the middle. Now, at this point, you start going upstream. You go upstream. I'm going to take that 4 and put him up into one of these guys who only has 2 variables. This one only has an x and a y. So since I know what y is, I can stick it in to figure out what x is. So I'm going to take that number 4. I'm taking number 4. I'm taking number 4, and I'm plugging in the 4 for my y. So that's going to be negative 46x. What's 4 times 46, guys? 140 what? 184 y. Oh wait, no, I'm putting 4 in there. 100, what did you say, 184?
Yeah.
Equals negative 46. So negative 46x equals 184 minus 46. I'll bring 184 over. 184 minus 46. 138. Okay. So that makes x, and that goes in negative 3 times. Negative 3. Okay. So that is my x. That's my x. So now I'm going to take those two, my x and my y. I'm going to go back upstream again. Upstream again. When I go upstream, I'm going to be taking my x equals negative 3 and my y equals 4. That's what I'm taking as I go upstream. And I'm gonna go all the way up to my original box. Alright, so I need a big map or something. So I'm taking my number 3, my original number 3, and I'm plugging in a what for x? -3 for x, and what for y? 4 for y. I don't know what z is. So 12 minus 8 minus 5z is 9. Positive 12 in the front because it's a negative and negative. Awesome. 12 minus 8 is 4. So I'm going to take that 4 across the river. It'll be -4, which will make this 5. And z will be -1. Woo! -1. Oh, okay. Did I mess up somewhere? Where did I mess up? This is 12 minus 8. 12 minus 8 is a positive 5, right? But when I take it over here, it's going to be -5. Oh, it's positive 5. This is a positive 12 minus 8, right?
Yeah.
Which is a 4 minus 5z. Oh, I wrote the equation down wrong. See how easy that is? Yeah, burn it. Yeah, look. Just one little thing, and I've done all the work. Okay. Good thing we have 30 eyes on this. So this is a plus, makes this a plus, which makes this a plus, which makes this a 5, which makes Z a positive 1.
Yeah. Sweet.
Sweet.
Forget that.
Wow.
I think
All
that's
right.
good enough.
Yeah.
Question.
Yes.
How many meters are on the helmet?
Not a whole lot, but there are a few. I need to show you one other thing before you freak out. We're not gonna.
Oh.
No. Listen. What did we discover yesterday? You can get rid of denominators just like that.
Oh.
And I'm going to show you how easy you can get rid of them. Okay? All right, what's the denominator on that first problem? 2. So I'm going to take that 2 and I'm going to multiply both sides by 2. When I distribute this, what's 2 times x? Thank you very much. What's 2 times a half? So that's 1z. Wait, 1y. Oh, forgot the
Doesn't
y.
matter.
Oh, it definitely matters. And then I'm going to do it to the y and the z, so z would also be a y. Z would also be a y. 1. And here. So I just got rid of it. I'll never have to look at those fractions again. Never. In that line. All right, what's my power denominator here? All right, so we multiply both sides by 4. When I multiply 4 times 3/4. 4's cancel. What's left? Yes. 4 times a 4th. 1. Yeah, just 1. So that's 1. 4 times 3 halves. Because 4 times 3 would be 12, divided by 2 would be 6. And then these 4's cancel, and I've got a 7. Done with those fractions. Last but not least, what's the common denominator here? 6. What's a third of a 6?
2.
2. What is 6 times 2? 3 halves. That would be 6 times 3 is 18, divided by 2, 9. then 6 times 2/3,
Four.
so it is 4. And 6 is canceled, 13. So now, we're gonna erase all this. You're good as even there.
And do this.
Yes,
So when we do it from, there's not even the answer to fraction.
when you have this problem, I'll tell you right now, one of them is a 0.5,
Oh.
but the other two are whole.
What, is this gonna be actually?
Well, there's three total.
Yes, not exactly, but one line.
That's great.
Okay? All right, so, I'm not gonna do any more, you've got it. Notice, these two, do not solve these two, only set them up, okay? And I will even go so far as I'm gonna tell you what the answers are ahead of time, so that when you're working, and if the first variable comes out wrong, you know to stop and go look for a mistake, so we'll get to the end and figure it out, okay? So hang on just a minute and I'll.
I would say my own is so.
These two, you're just plugging in values. If they're doable. Number 9. The solution is 1, 5, 6, 10. The answer is -3, -1, -1. And 10. Six is gonna be -0.5, 1. And then there's what you just said.